Okay, I think we're recording. Yep, good. All right. So this is question 9 that you're asking me about. All 3 of these questions give you a volume. Okay. 2 of them are about molarity, and the one in the middle there is about molality. So just remember that your formulas that you're using. So molarity, which is capital M, is equal to the moles of solute divided by the volume in liters. Okay, whereas the molality is equal to moles of solute divided by kilograms of our solvent. Okay, so molality, I've got water. Water, so 1 cubic centimeter, right, is equal to 1 gram of water. Okay, I got 300 cubic centimeters of water. That's 300 grams. Well, I need kilograms. The first thing you got to do with this one here is to go from 300 grams, because that's what it is, right, to 0.3000, because of all the zeros there, they're significant, kilograms. So that's your mass of solvent, okay? This one here, the letter A, that one is milliliters, right? You need to make that one liters. So again, 750 milliliters is equal to 0.75000 liters. I'm keeping all the sig figs. So we got those 2 correct. The last one down here, it also needs to be in liters. So again, 250 milliliters is 0.2500 liters. So now everybody's in the right thing down there. I don't have to convert any of the stuff here on the right over here. These guys are good to go. I don't have to do anything with them. So we just plug them in, all right? And all of our answers here are going to give us a number of moles. And then we have to use molar mass to find the grams. So the first step is to make sure everything is the right unit so I can plug it into the equations. And right here, this is how they need to be. This is where you need to get them started, okay? So let's do A as your example, okay? So A, we're going to solve for our solute. So molarity is, remember this, okay? We're going to solve for moles. N is moles. So really, to change this into that, algebraically just kind of move it around. N is equal to the molarity times the volume, okay? So to do that, we just take the molarity, which is 0.5, right? And we multiply that by the 0.75. All right, and what we get, so 0.5 times 0.75 is 0.375. Okay, not done yet, because this here is moles. I need to take this, so I'm just gonna do the calculation for molar mass, and I'm going to add it on there. So we're going to basically go here, and what I'm going to do is I'm going to multiply it by its molar mass. Now I've got to find this, the molar mass. To do this, because I'm going to multiply it by the molar mass to do it, to find the final answer, but I got to find the molar mass. So calcium, so if I look at my periodic table, calcium is, so we're looking at this substance here, okay? So calcium is 40.078. Chlorine's 2 of those guys, so 2 35s, basically. So we add all those up, okay? So 35.453 twice plus 40.078. And we get our molar mass here, that's going to go right there, is going to be 110.984. Okay, so now that we have the molar mass, we can multiply the number of moles that we were given in letter A. So this right here, multiply these 2 things, okay? So 110 times 0.375, and I get 41.619, okay? And this is grams, but we have to look at sig figs again, right? Sig figs in my initial source material is 2 here, and of course 5 there, and molar mass is 5. So 2 is my least amount, so I'll look at my first 2. The 6 can change, so the final answer becomes 42. So 42 grams of calcium chloride. So that's the first one. The third one's just like that one. It's the exact same process. Now, B is a little different. B I'm solving with molality, so I have to use a different formula. Formula I have to use for that one is going to be that, whole lowercase m is equal to moles of solute divided by kilograms of solvent. All right, so we got our kilogram solvent, we got our molality. We're going to solve for n, so it kind of looks the same. So lowercase m times kilograms of solvent. And so that's going to be 2.50 times 0.3, basically. So 2.5 times 0.3, and I get 0.75. And looking at my sig figs, so 3 and 4, basically that's what I get. Okay, so this here is moles. I have moles now. Now, I don't want moles, I want grams, so I have to do the same thing I did earlier. So now I'm looking at hydrogen peroxide. So hydrogen peroxide has a different one. So it's going to be basically the mass of water. If you remember, water is 18.015 plus another oxygen, so 15.999. So that's the molar mass, if you're wondering. So 18.05 plus 15.999. That's 2 hydrogens and 2 oxygens added together. And I get this again, the mass on top, so 34. So 34.014 over 1 mole. So the moles cancel and we get just multiplication. So that molar mass times 0.750. And I get this from my calculator answer. All right, and if you look at your sig figs once again, and always look back at your sources. So I've got 3 here, 4 there. My molar masses are going to be 5 each, so 3 is my least. So I look at my first 3, that 1 can't change it, so my final answer there becomes 25.5 grams of hydrogen peroxide. And there you go. So there's 2 of the examples. I'll let you figure out C on your own, but that should kind of get you on the right path. Hope it helps.